A one-dimensional array will be given that may contain both positive and negative integers. We'll have to find the sum of contiguous subarray of numbers which has the largest sum and then return its sum. Here is an example and we can see 6, minus 2, minus 3, 1, 5 subarray has the largest sum which is 7. We can use different approaches to solve this problem like using divide and conquer strategy, brute force solution, greedy algorithm, Kazan's algorithm. For now, we'll use divide and conquer algorithmic paradigm. Algorithm formulation or idea. Divide and conquer is an algorithmic design paradigm which recursively breaks down a problem into two or more subproblems of the same or related type until these become simple enough to be solved directly. This strategy has basically three parts. Firstly, divide the problem into several smaller subproblems, then conquer the subproblems by solving them recursively, and finally, combine the solutions to get a solution to the subproblems. Let's elaborate this to understand better. We can see this is a recursive solution wherein we would divide the array into two halves and return the maximum of the following three. First is the left half, second is the right half, and third is the cross sum. For finding the cross sum, we would find the left subsum, which is the maximum sum starting from the midpoint and ending at some point on the left of mid. Similarly, find the right subsum, which is the maximum sum starting from mid plus 1 and ending with some point on the right of mid plus 1. Finally, cross sum is the addition of the two. So here is the pseudocode of our algorithm. We have method max subarray and we are sending array address A leftmost index as left, rightmost index as right. Then we'll check if left and right indexes are equal or not. If they are equal, we'll return left index, right index and the value of the index. Then we'll go to else. For finding midpoint, we'll add left and right index and then divide it by 2. Then we'll go to L1. L1 is recursively calling maximum subarray method. And we are sending mid value as right. From here, recursion will go on and it will break the arrays into individual sub-arrays. When left and right indexes are equal, it will return the indexes and its value to the previous recursion method. Similarly, we'll calculate R1 and take mid plus 1 as left. Then we'll calculate M1 likewise. After calculating L1, R1 and M1, we will check which one is the largest among these three. So if L1 is greater than R1 and M1, we will return L1, and if R1 is greater than L1 and M1, we will return R1, otherwise we will return M1 to the previous recursion method. That's how it will go on and on until we get the maximum subarray sum. Things will be more clear when we will see the simulation. Here is our input array. We will divide the array into two halves. For this, we will use pivot. Pivot is basically the midpoint of the array. Left half is the array from starting index to the pivot element and right half is the array from pivot plus 1 till the end. Similarly, we will divide the array further till we have individual elements. For now, we will take the left half of the array and traverse upwards, merging the solution from the sub-arrays. We will start working with the element -2 and -5. So here -2 is our pivot element and -2 is the left sum, -5 is the right sum. Left subsum -2, right subsum -5. Then we'll calculate cross sum. Cross sum is the summation of left subsum and right subsum. So here cross sum is -7. Then we will calculate maximum sum. Maximum sum is the maximum value among left sum, right sum and cross sum, which is here -2. So we got -2 as maximum sum from this array. Similarly, we will calculate right side of the array, and we got 6 as the maximum sum. Moving upwards, we have already calculated left and right sum. As -5 is our pivot element, left subsum will be the maximum sum starting from the pivot and ending on the left. So while traversing to the left, the first left subsum will be -5 itself. The second left subsum will be the sum of pivot and left element. Then we'll take the maximum value between these two. So here maximum is -5. Similarly, we'll calculate right subsum. For calculating right subsum, we'll start from pivot plus 1 till the end. Then calculate cross sum. Cross sum is here 1 and maximum sum is 6. So here we got 6 as the maximum sum from the left side of the input array. Now my partner Yasin Mahmood will continue from now. Thank you.
Hello, I'm Yasin Mahmood. My student ID is 191013446. I'll be explaining the right side of the simulation. As we can see from the slide that our pivot is -2. With the help of the pivot, we divide the array into subarrays and will continue to do so until we have individual subarrays. In the bottom left of the slide, we can see that -3 and 1, both of them are individual subarrays. -3 is left subsum and 1 is right subsum. For cross sum, we add left subsum and right subsum, which is -3 plus 1 equal to -2. Now we have to find out the maximum sum. To find out the maximum sum, we have to compare left sum, right sum and cross sum. Left sum, which is -3, right sum, which is 1, and cross sum is -2. Among all of these sum, right sum is the highest, 1. So we take 1 as the maximum sum. Similarly, from the bottom right highlighted subarray, we'll get 5 is the maximum sum. If we calculate it more further, we'll get 6 is the maximum sum in the highlighted subarray. So from the left side, left sum is 6, and from the right side, right sum is also 6. We have to find out the cross sum. Starting from pivot -2, if we move left, calculating the sum of each index, we'll get -2, -2 plus 6, -2 plus 6 minus 5, -2 plus 6 minus 5 minus 2. If we calculate it more further, we'll get 4. We'll take 4 as the left subsum. Similarly, we'll get 3 as the right subsum. For cross sum, we add left subsum and right subsum, which is 4 plus 3 equal to 7. So we have to find out the maximum sum. So maximum sum, we compare left sum, which is 6, right sum, which is also 6, and cross sum, which is 7. If we compare all of this sum, we'll get 7 is the highest of all of this sum, which is also the result of maximum subarray sum. Time complexity analysis. To find out maximum cross subarray, it takes order of n times. Recursive call on input size takes n by 2 times. So if we call it twice, then the result will be 2t of n by 2 times. Hence the equation is t of n equal to 2t of n by 2 plus order of n. If we calculate the equation recursively, we will get t of n equal to 2 to the power k t of n by 2 to the power k plus kn. If we break down the equation more further, we will get the time complexity of order of n log n. Use case and variations. Divide and conquer strategy is the basis of efficient algorithms such as quick sort, mass sort, etc. Moreover, we can use this strategy for multiplying large number or finding the closest pair of points. Furthermore, we can apply this strategy for syntactic analysis or computing discrete Fourier transform. We can solve maximum subarray problem other than using divide and conquer strategy. The alternative solutions are brute force algorithm, greedy algorithm, and Kadanes algorithm. In brute force algorithm, we have to compare all the possible continuous subarray, which will increase its running time. In greedy algorithm, we would initialize two variables, current sum and max sum, with the first value of input array. The current sum will hold local maximum sum and max sum will hold global maximum sum. For each input element in the array, we will update current sum with the maximum of either the sum with current element or current element itself. The max sum will max of itself or current sum. The result would be max sum. In Kadanes algorithm, it uses dynamic programming. It is similar to greedy algorithm with one difference. Instead of storing the current sum in separate variable, we will update our input array. We have time complexity of different algorithms. First we have divide and conquer algorithm, which takes order of n log n times. Then we have brute force algorithm, which takes order of n squared time. Then we have greedy and Kadanes algorithm, which takes order of n times. We can see that divide and conquer algorithm takes the least amount of time, which makes it most efficient for solving maximum subarray problem. Thank you.